Bitwise operators. Bitwise operators are used to perform operations on the individual bits of integer values. These operators allow you to manipulate and compare binary representations of numbers. We have two variables x and y. X is assigned with the value 5. In binary, it is 0101. Y is assigned with the value 3. In binary, it is 0011. Bitwise AND. It returns a new number where each bit is set to 1 only if the corresponding bits of both operands are 1. Applying bitwise AND on x and y would give us the binary result of 0001, which in decimal stands for 1. So, in this case, only the last digit of both operands are 1. So, the binary representation would also have 1 in the last digit. If either of the operands have 0, the output would be 0. Bitwise OR. It returns a new number where each bit is set to 1 if at least one of the corresponding bits of the operands is 1. In this case, the first digit of both operands is 0, so the output is also 0. In all other digits, either of the value is 1, so the output will be 1. Bitwise XOR returns a new number where each bit is set to 1 if exactly one of the corresponding bits of the operands is 1. In this case, first digit of both operands is 0 and last digit of both operands is 1. So the first and last digit will be set to 0. Only if one of the operands is 1, then the output will be 1. Bitwise NOT flips the bits of a number resulting in the ones complement of the number. Here x is 5. Applying bitwise NOT would return us ones complement of 5, which is minus 6. Left shift. It shifts the bits of a number to the left by a specified number of positions. This operation effectively multiplies the number by 2 raised to the power of the shift amount. So the value of x is 5. When it is shifted to left by 2 positions, the binary output would be 10100, which in decimal is equivalent to 20. Right shift shifts the bits of a number to the right by a specified number of positions. This operation effectively divides the number by 2 raised to the power of the shift amount. Here x is assigned with the value 20. In binary, it is 10100. When we apply right shift, the binary output would be 00101, which in decimal is 5. There are membership and identity operators as well. We'll see them later in the course.